Let me walk you through the incredible phenomenon where mirrors can literally create light from nothing, all thanks to the strange quantum world and the Casimir effect. This isn't science fiction, but real physics that's been demonstrated in laboratories. Picture two perfectly smooth mirrors placed facing each other in complete darkness, separated by just a few nanometers. That's about 1,000 times thinner than a human hair. In our everyday experience, nothing should happen here. But in the quantum realm, something extraordinary occurs. The empty space between these mirrors actually crackles with invisible energy that can be transformed into real, detectable light. Here's how it works. According to quantum physics, what we think of as empty space is actually a seething sea of temporary particles constantly popping in and out of existence. These are called virtual particles, and they include virtual photons, fleeting packets of light energy that normally disappear as quickly as they appear. The key is that between our two mirrors, only certain wavelengths of these virtual photons can exist, while outside the mirrors, all wavelengths are possible. When we suddenly move one of the mirrors, either by vibrating it extremely fast or quickly pulling it away, we dramatically change which wavelengths fit between them. This rapid change is so abrupt that some of those virtual photons don't have time to disappear back into the vacuum. Instead, they get promoted into real photons, actual particles of light that we can detect. Essentially, we've converted the quantum foam of empty space into real electromagnetic energy. Scientists at Chalmers University of Technology in Sweden actually made this happen in 2011. They didn't use physical mirrors moving at impossible speeds, but instead created an artificial mirror using superconducting circuits that could effectively move at nearly a quarter of the speed of light. By carefully controlling these circuits, they were able to produce real microwave photons from what was essentially nothing but vacuum fluctuations. The light they detected matched perfectly with quantum mechanical predictions. This effect, called the dynamical Casimir effect, shows us that the vacuum of space isn't really empty at all. It's more like an invisible ocean of potential energy that we can sometimes tap into under just the right circumstances. While we're not going to be extracting useful amounts of energy this way anytime soon, the effect is incredibly small and requires extreme conditions. The implications are profound. It teaches us that the line between something and nothing in quantum physics is much blurrier than we might imagine. The vacuum isn't just empty space waiting to be filled. It's an active participant in the quantum world, capable under the right conditions of producing real particles from what appears to be nothing at all. This discovery not only confirms some of the strangest predictions of quantum field theory, but might one day lead to new technologies that harness these quantum vacuum effects in ways we're only beginning to imagine.